we are discussing about order properties. We discussed the various consequences of order properties, right? So, product of two numbers is 0, then one of them must be 0, or then either both are positive, both negative. So, now we'll see further some applications of properties. So, somebody asked this question: where do we see that the properties of commutativity or other some properties fails? So, this property, commutativity of multiplication, fails in matrices. If you take two matrices and multiply them, you find that the product of A and B is not same as product B and A. Right? So that you can check. Please keep your mic off. So don't forget to keep your mic off. Okay, so we discussed this last time. Now we'll see some applications so that can have the use of this determine the set is equal to real numbers for which x square is greater than x square is greater than 2x minus x 2x minus 1 2x square is greater than I want 2x minus 3. Can you determine this set? So that means you want to determine all the real numbers that satisfy this inequality. Right, so all real numbers that satisfy this inequality. So if a real number is in A, then it satisfies this inequality ki x square is greater than 2x minus 3, right? That means x square minus 2x, okay, let us take here, plus then x square minus 2x minus 3 greater than 0, right? So this will be the condition satisfied by x if x is member of set, and therefore we want to determine all the elements, all the real numbers that satisfy this inequality. Now note that the x square minus 2x minus 3, can we factorize this, right? And what are the factors? So what are the factors?
X minus 3 and x plus 1.
X minus 3, x plus.
Very good. Therefore x square minus 3x 2x minus 3 greater than 0 is equivalent to saying that this product x minus 3 into x plus 1 is positive. That means product of two brackets is positive, but x is a real number, right? We have selected a real number from set A, and that A satisfies this property. X minus 3 and into x plus 1 is positive, so product of these two real numbers is positive. And then recall our yesterday's discussion. Then there are two possibilities. So what is the case 1? What are two possibilities if product of two numbers is positive?
Both should be positive.
Right. So then case 1, x minus 3 is positive, and x plus 1 is positive, and case 2, second case is x minus 3 is negative and x plus 1 is negative. So these are two possibilities. Now let us see, right, so this is OR, right, so either this is true or this is true, OR. So x minus 3 is positive is equivalent to saying that x is greater than 3, and x plus 1 is positive is equivalent to saying that x is greater than minus 1. So uh, here 0, so x is greater than 3, that means x is on this side, and x is minus 1, that means x is on this side, and intersection, so and means what? Intersection of these two conditions. So x is greater than 3 and x is greater than minus 1. What is equal, what is a and means, what is the intersection of these two conditions? X is
X is
greater than,
greater than 3.
right. So if x is greater than 3, then it satisfies both of these conditions, this as well as this. So that is the intersection, right? So therefore, x belongs to, x is greater than 3 means 3 to infinity. That means x up to infinity and not equal to 3, so greater than 3. So that you can understand this notation. Fine. Now from second condition, what happens? X minus 3 is negative. That is equivalent to saying that x is less than 3. And x plus 1 is negative is equivalent to saying that x is less than minus 1. So, and therefore, what is the intersection of these two conditions? This and this. So, this is 3 and minus 1 is here, x less than 3 and x less than minus 1. And so, what is intersection? Common is this, less than minus 1, right? So, here it is common, both of these things are true. Therefore, this is equivalent to saying that x is less than minus 1, and therefore where is x? X belongs to minus infinity to
Plus
minus,
infinity to minus 1.
right? So every real number satisfying this, and therefore or means what? Union. Therefore if x is in A, then x is in 3 to infinity, or x is in minus infinity to minus 1. But or means what? Union. Therefore x is in minus infinity to minus 1 union 3 to infinity, and thus what is our set x? X is in A, then x satisfies this condition, or x is in this set, and therefore what is set A? A is minus infinity to minus 1 union 3 to infinity, which is equivalent to saying that x is a set of all those real numbers which are less than minus 1 or greater than 3. So this is another different way to uh, uh, write the set A, right? So this is a set, and therefore what are all the real numbers that satisfy this inequality, right? So this is a one way. So this is one way. Alternative, can you tell me the alternative way? So alternatively, so x square minus 2x minus 3. So can you convert it into perfect square? X square, right? So I want to convert it into perfect square. So minus 2, right? X perfect square means what? I want some x minus a square plus some constants. I want to get in this form, right? So
Add
can you
and
write?
subtract 1.
So because perfect somewhere if some bracket is a perfect square, then x square minus 2x plus a square plus b, right? So here 2 times something, and what is a in this case? 1, and then next term is its square, so I should add 1. So here 1 1 and subtract 1 and minus 3 as it is. So the expression, value of expression is not going to change. I am just modifying, right? So I am just manipulating some terms, so otherwise value is same. I have added 1 and subtracted 1, so nothing is changed. Just I am adding 0, which is additive identity. So if we combine these three terms, it is x minus 1 square, and if I combine this This is minus 4. Right. Now, if I call this as y, then what I get, y is equal to x minus 1 square minus 4. Right. That means I can write it as y plus 4 is equal to x minus 1 square. Now, you know what is a parabola y is equal to x square? Do you know this parabola? Y is equal to x square. All of you know this, right? This is a parabola y is equal to x
Yes.
square. Now, what is the vertex of this parabola, right?
0, comma 0.
0, comma 0. Now, if I shift my vertex to minus 4, comma 1,
Yeah.
right?
It's 1 comma minus 4.
1, comma minus 4. 1, comma
Uh,
minus. If I shift my vertex to 1, comma minus 4, what I will get? What will be the parabola? So 1 and minus 4. So this is the point 1, comma minus 4. So I will shift this vertex, then what I will get? So I will same parabola, but I am just shifting the vertex, right? So this parabola I will get. Am I right? And what is the equation of this parabola? This is equation of this parabola. Right? Am I right?
yes, sir.
Right. So if I shift this vertex to this, that means I just shift this parabola to vertex to this point, I will get this parabola. And what are the values of y which are positive? What I want, so I want that key x square minus 4x minus 3 is positive. That means I want, so this I want. What I want x square minus 4x minus 3 positive. That means
Sorry,
what y
2x. Huh?
I want y 2x, right? Very good. 2x minus 3 positive. So I want y positive, right? So on parabola, what are the values of x for which y is positive, right? Because I am saying that y is equal to x square minus 2x minus 3, and I want this is to be positive, means y positive. And see the graph parabola where it intersect x-axis, where it intersect x-axis when y is 0. So when y is 0, if I put y is equal to 0 in this case, right? So y is equal to 0, that means what is intersection with x-axis? So y is equal to 0 means x square minus 2x minus 3 is 0. That means x minus 3 into x plus 1 is 0. That means x is equal to 3 or x is equal to minus 1. So what are the points? So my figure is not perfect anyway. So this is my, and this is 3. At 3 and minus 1, it intersects with x-axis. And what are the values of x for which y is positive? What are the values of x for which y is positive? Every x after this, right? Every x on this side. If I choose this x, then for that value of y is negative because it is below y-axis. Am I right? Do you understand what is going on?
Yes, sir.
Do you
Yes, sir.
right? And
Yes,
just
sir.
from this picture, what is the set x such that x square minus 2x minus 3 is positive, or x square is greater than 2x plus 3. So what is this set? Can you understand this set now? From this picture it is clear. It is the set of those x such that x is less than minus 1 or x is greater than 3. Right. So this is another way, geometrical way, you can just sketch the parabola and where it intersect x-axis, and then on this side it is positive and on this side it is positive. So my set is minus infinity to minus 1 and 3 to infinity. That's it. This is alternative way, but there are several techniques. The only thing is how you use mathematics to understand such kind of things. All right. So this is clear. Okay. So determine the set of A, right, such that x is greater than 1 by x. So you determine this set. right? So what is the set of real numbers for which x is greater than 1 by x? So x is greater than 1 by x. So you can make various cases. So make problem very simple so that we can uh, write the answer easily. So there will not be any confusion. So for example, if I look at 2 and 1 by 2, which is greater? 2 is greater, right? Am I
2.
right? Very good. So in this case, 2 is greater than. But if I take x is equal to 1 by 10, and what is 1 by x?
10.
10. Very good. So in that case, 1 by x is less than 1 by x is greater
Great.
than.
Yes.
Right. So therefore, x is 1 by 10. Such x do not satisfy this property. Right. But if x is 2, then it satisfies. So from this, what is your observation? Can you get hold of all such elements which satisfy this inequality and which do not satisfy this inequality?
X should be greater than 1 or x should be less than -1.
So this is a good observation. Now if x is minus 1 by 10, then what is 1 by x? Minus 10. In this case, what happens? Which is bigger?
Minus 10 is greater.
So minus 1 by 10 is bigger than minus 10, right? That
Yes.
so x is greater than 1 by x. But if we take x is equal to minus 2, then 1 by x is minus 1 by 2. So which is bigger in this case?
-1.
I do.
So minus 1 by 2 is bigger than minus 2. That means 1 by x is bigger than x. So in this case, our inequality fails, right? In this case, inequality fails. In this case, it is true. In this case, it is true. And therefore, see, you should work out with simple examples and then generalize how to get hold of all the numbers, right? So from this, so what should be the general proof? This for particular choice, it is not sufficient. It is just for understanding. Otherwise, now if x is greater than 1, then x is greater than 1, then what?
X is greater than 1 by x.
Then x is greater than 1 by x. Can you prove this?
Sir, I did graphically.
Graphically, that is fine. That is one way, right? But using basic axioms, can you prove it? Right? So if x is greater than 1, so then 1 by x is greater than less than x. So that we need to prove. So suppose you want to prove this, right? Suppose you want to prove this. How will you be proving this?
So,
Right?
we can use the multiplicative identity here, right?
Huh. Then
Like x into 1 by x equals to 1, and now x is greater than 1. So, 1 by x have to be 1 less than 1.
no, why? From this it is not clear, right? Okay, so x is greater than 1 by x, that you need to prove. So if x is greater than 1, that means x is 1 plus some alpha or some alpha positive, right? When I say x is greater than 1, then x is 1 plus something, that quantity is alpha, right? That quantity is alpha. Am I right?
Yes, sir.
Difference is alpha. Now, what is 1 by x? 1 by x is 1 upon 1 plus alpha. 1 upon 1 plus alpha. So, if x is less equal 1 upon x, on the contrary, suppose this is not the case, ki x is not greater than 1 by x, then it is less equal. Then what will happen? Then 1 plus alpha is less equal 1 upon 1 plus alpha, and 1 plus alpha is certainly positive. So what will happen then? 1 plus alpha square is less than or equal to 1. That means, now expand this bracket. Expand this bracket. What is the expansion of this bracket? Am I right? So whatever I am writing is correct? Is it correct?
Yes, sir.
Now expand this bracket. So 1 plus 2 alpha plus alpha square less than or equal to 1. Right. That means 1 plus some beta is less than or equal to 1. What is beta? 2 alpha plus alpha square, which is positive quantity. What is a contradiction? Is it a contradiction?
Yes, it is
Yes, sir.
contradiction.
We realize there is a contradiction key. 1 plus some positive amount is less than 1. That is not true. Contradiction. And therefore what we should say that this is not possible. Hence, when we say that x is less equal 1 plus x, this is not possible. Hence, x is greater than 1 plus x if x is greater than 1. And where we use the property that x is greater than 1, we use the property that if x is greater than 1, that means x is 1 plus some positive amount. Right? When I say x is greater than 1, then there is some gap between x and 1. That gap is alpha. So therefore x is 1 plus alpha. And that gives us x is greater than 1 by x. So that is clear. Right. So this is first thing. What is second thing? Now see, try to dissect your problem in small pieces and then combine, because sometimes it is difficult that you get the complete solution at a time. That is not possible, or that is difficult in some sense. So split your problem into simple cases. So what is the second? So therefore, if x is greater than when, we know that every element on this side satisfies our inequality, and therefore every element will go inside set A. Right. Now second of case, if 0 less than x less than 1. If x is equal to 1, then this is not satisfying our inequality, right? Therefore 1 is not included in set. If 0 less than x less than 1, then prove that 1 by x is less 1 by x is greater than x. You check this. If x is less than 1 means what? How will you prove this? If x is less than 1, then 1 by x is greater than x. How will you prove this? Use the simple logic, whatever we discussed so far.
Minus alpha.
So if x is less than 1, then when I say x and less than 1 and it is greater than 0, so it is 1 minus something. So you have to go to this side. So it is, then x is 1 minus alpha, some positive alpha, for some positive. So if we have to subtract some positive amount from 1, then we get x, because we are saying that x is less than 1. Right, so we have to subtract some positive amount. So what is our claim? Then what is 1 upon x? 1 upon x is 1 upon 1 minus alpha. This is our claim. This is 1 by x. So what is our claim? We claim that 1 by x is greater than x. This is our claim. Suppose not. then 1 upon x is less than or equal to x, right? If not greater than less or equal, then 1 upon 1 minus alpha is less than or equal to 1 minus alpha. But what can we say about 1 minus alpha? Still x is positive, right? So I can multiply both sides by 1 minus alpha, 1 and 1 minus alpha, its square. Now, what can we say about here? Inequality, is it same? Will inequality remain same?
Yes,
Yes, sir.
because we are multiplying by a positive number on
Right,
both
very.
sides.
So that 1 is less equal, 1 is less equal, so expand this bracket, minus 2 alpha plus alpha square. That means 1 less equal, 1 is less than or equal to 1 plus alpha square minus 2 alpha. So what is a contradiction?
Sir, but we haven't proved that alpha square is greater than 2 alpha. So the number might be greater than 1.
Yes, number might be greater than 1, that is true. So what you can say in this case?
Take a case.
So okay, but where is alpha?
Sir,
Alpha
it's
is
4 alpha, no?
okay. Observe one more thing. 0, 1, and x is here. So
Sir,
therefore, x,
so sir, you could consider alpha between 0 and 1 just for the case right now to
no,
make
no,
it.
that is actually the case. That is what I want to tell you, because my
Okay.
x is in between 0 and 1, and how much amount we can subtract from 1 so that I will remain between 0 and 1, right? So 0 less than alpha less than 1. I
Yes.
cannot
Yeah.
subtract the amount which is bigger than 1. Suppose I subtract 2 from 1, what I will get? Minus 1, which will not
Minus
remain
1.
in 0, right? So I am talking about x between 0 and 1, and therefore x is 1 minus alpha, and that alpha is necessarily less than 1 and greater than 1. Right. So
Okay.
if I subtract some alpha which is greater than 1, certainly it will not remain in this. So my assumption is x between 0 and 1. That's why my alpha is between 0 and 1. That ultimately there. Right. So since 0 less than alpha less than 1, uh, then can you say that then prove that alpha square is less than alpha? Am I right? Can you prove this? If alpha between 0 and 1, then alpha square is less than alpha.
Yes, sir.
Yes, sir.
If number is less than 1 and greater than 0, then its square is always less than the number.
Sir, can we consider the opposite case, that is alpha square is greater than alpha, and then multiply both side by the multiplicative inverse, that is 1 by alpha.
Okay, so let us
You can't consider like that.
suppose alpha square is not less than alpha, and I am assuming alpha is less than 1. Suppose alpha is not less than alpha. That means alpha square is greater equal alpha. That means alpha square minus alpha is greater equal 0. That means alpha times alpha minus 1 is greater equal 0. Right? Am I right? But then both product of two numbers is greater equal 0. That means either alpha is greater equal 0 and alpha minus 1 is greater equal 0, or alpha is less than or equal to 0 and alpha minus 1 is less than or equal to 0. But if alpha is greater than 0, so that is true. That means and alpha is greater than 1. So is it possible? What first case gives? Ki alpha is greater equal 0 and alpha is greater equal 1. Is it possible? That means alpha is greater.
No.
So this gives that alpha is greater than or equal to 1, which is not possible. What this gives? Alpha is less than or equal to 0, right? And alpha is less than or equal to 1. So what is the combination of these two? Alpha is less than or equal to 0, right? So this is also not possible, and therefore if alpha square is greater equal alpha, implies alpha is less equal 0 or alpha is greater equal 1. So in any case, there is a contradiction. Do you understand this? Do you understand this what I have written, or shall I write it again?
कळलं sir.
Okay, very good. So, and therefore if alpha is less than 1, then alpha square is less than 1. That is clear. Or you write down the detailed proof. I have just written here in short, but you write down this proof in detail. Anyway, fine. So, so that alpha square minus 1 is negative. Alpha square minus alpha is negative. Is it clear? Alpha square minus alpha is negative. Am I right?
Yes, sir.
Very good. Therefore, 1 plus alpha square minus 2 alpha is 1 plus alpha square minus alpha, right? 1 plus alpha square minus alpha. So this bracket is negative. Do you realize this?
Yes, sir.
Yes, sir.
Observe that alpha square minus alpha, which is alpha square minus 2 alpha, is negative. Negative, right? This is clear because my alpha is less than 1, so alpha square is less than alpha, so alpha square minus alpha is negative, and therefore 1 plus alpha square minus 2 alpha I can write in this way, and so ultimately I get that this bracket is negative. Bracket is negative means alpha square minus 2 alpha is negative. Therefore, 1 plus alpha square minus 2 alpha, what can we say about this quantity? Is it less than 1?
Yes, sir. Yes, sir.
Yes, sir.
Why this is less than 1? Because I am adding negative amount. I am adding negative amount to 1. So certainly this quantity will be reduced. It is less than 1. Right. So this is my expression 2. And what I got here actually expression 1. Now observe this. Contradiction. Do you realize that there is a contradiction?
Yes, sir.
So thus, so from 1, we get that if from 1 we get that if 1 by x is less than or equal to x, then 1 is less than or equal to 1 plus alpha square minus 2 alpha, which is less than 1. Contradiction from 1 and 2. The contradiction. Right. So what contradiction we got? 1 is less than 1, which is not possible. Hence, our assumption. What was our assumption? What was our assumption? Ki 1 by x less than or equal to x is false. Right. 1 by x. Right. 1 by x. For which case we are discussing the 0 to 1. Thus, hence, 0 less than x less than 1. If then what?
1 by x is greater than x.
1 by x is greater than x. If 1 by x is less than or equal to x, and for such x, 1 by x less than or equal to x, that gives us contradiction. And therefore, we have to accept that if 0 less than x less than 1, then 1 by x is greater than x. That's fine. So, now the next two cases are very easy. If you,
Excuse me, sir.
yes,
Sir, will you please go back to the first inequality, inequality 1?
which,
Yes, sir, this one.
uh,
You have marked 1.
one, okay, this is one.
No, sir. You have in the second step, you have marked inequality 1 and 2 and made the contradiction. No,
This
that
one.
yeah. This one. So in the previous line, we are seeing that 1 is less than 1 minus 2 alpha plus alpha square.
Yes.
So if we subtract 1 from both sides, then we get 0 is less than equal minus alpha plus alpha square. So from that we get 2 alpha is less than equal alpha square,
Yeah,
right?
that is also right.
So as alpha is a greater than 1, so using the property proposition we have discussed yesterday, that 1 plus a plus c is less than b plus c, as a is less than b. So from that we can conclude that this inequality is not possible. So we
Yeah.
can we use that property in
Yes,
this case?
absolutely. Absolutely, you can use.
I
See,
think it will be easier, right?
yeah, whatever is convenient, whatever is possible, you can use your own way, right? That, see, most of the time, what I do go to the basic fundamental things. Observe what is which is greater and which is smaller. But if you have the another method, that's fine. If it is technically correct, then no problem.
Okay,
But
sir.
anyway, this is not possible. So anyhow, you will get some contradiction either this way or that way,
Yes, sir.
right?
Yes, sir. Thank
Fine.
you, sir.
Okay, so now what is the third case? So, okay, we are treating third case now. Third case, minus 1 less than x less than 0. So, if x is in between minus 1 and 0, then what can you say about 1 by x? As we observe, like minus 1 by 10 and 10. Then x is, suppose I take x is equal to minus 1 by 10, and then what is 1 by x? Minus 10. So 1 by x is smaller, right? Am I right?
Yes, sir.
So you write down the proof like previous case, previous similar lines you can write down the proof, because the only minus sign is the case in that case. If my x is, what is the proof? Proof is very easy. When I say x is negative and less than minus 1, greater than minus 1, then I can multiply both sides by minus 1. I will say y is equal to minus x. Then what I have? So 0 less than y less than 1. And then treat this case. In this case, what happens? If y is between 0 and minus 0 and 1, what happens? 1 by x is greater than x. 1 by y is greater than y. That means what is y? Y is minus x. So minus 1 by x is greater than minus x, and multiply both sides by minus 1. So 1 by x is less than. That is what the use the previous case. Do you understand what I am saying here?
Yes, sir.
Right. So therefore this case is trivial now. Now fourth case, if x is less than minus, again use the first. Here you can use second case, and here use first, right? And what happens? Just think about x is equal to minus 10. 1 by x is equal to minus 1 by 10. And what happens in this case? 1 by x is x. And so what is true in this case? X is less. And what is the proof? Use the previous case, first case, that is observation. And what is the final conclusion? This final the combine all these cases, the set A of those real numbers for which x is greater than 1 by x. What are those numbers? Now tell me what are the numbers. From first case, if x is greater than 1, what are the numbers greater than 1 satisfying inequality? All, right? All x greater than 1 satisfy this inequality. So therefore, what is my set A? So all x which are greater than 1, right? Because every x greater than 1 satisfy this union. Second case. From second case, did you find anything? From second case, if you x between 0 and 1, then for every such x, if x is between 0 and 1, for every such x, 1 by x is greater than x, so not x greater than. So from second case, we have not found anything, we didn't get anything. From third case, right, from third case means from this region, right? So every real number in this range satisfy this. No number from 0 to 1 satisfying this, and every number from greater than 1 satisfies inequality, and no number from 0 to 1 satisfies, and every number between minus 1 to 0 also satisfies, right? So what is the next addition to this set? X. So is that 0 less than what is next? Minus 1 less than x less than 0, right? And from third case, did you get anything? If x less than minus 1, then nothing, because in this case x is less than 1 by x for every such x. Therefore, if x less than minus 1, then nothing is found. If x between minus 1 and 0, then everything is there. X between 0 and 1, nothing, and x greater than everything. So what is ultimately our set? What is ultimately our set? The all numbers x such that minus 1 less than x less than 0 or x greater than 1. Or alternatively minus 1 to 0 union with 1 to infinity. So this is an alternative way we can express this set. Fine. So is it clear? Any difficulty in this? Do you find it comfortable? Are you comfortable with this?
Yes, sir.
Very good. So now you think about many such sets, right? So only thing is you have to see while proving this we have proved many things in between, which we did not prove before. What we proved, if alpha is a number between 0 and 1, then its square is less than alpha. That is what we have proved in this process, right? More or what we proved in this process, many things we proved in this process, right? And while determining this set, we have proved that if x is greater than 1, then 1 by x is less than x. So many such things we have proved. And this is a way to kind of attitude, research attitude. So what people generally do research, people are doing research means they have some problem in their mind. It may be real life problem, right? What is a real life problem? For example, so you have a real life problem like how to get the medicine for coronavirus. This is the main problem. Then people are doing some work and they prove so small things. What are the small things? Okay, so if you wear a mask, then you can avoid coronavirus. Or there are these are the small results. People doing research on these kind of things, small things, right? So which medicine is helpful to get recover from COVID, right? So these are the small things. So similarly, our main problem was to determine this set. In that process, we proved small things, and that gives that is addition to our knowledge, and that new addition we can use for other purposes also, right? So this is what the philosophy is.
तर
When we
अजून एक
solve,
एक्झाम्पल द्या ना
okay,
प्रॅक्टिस साठी.
Yeah, so you take this set is equal to x such that x square is greater than 1 by x. So you try to solve this. Second, take set B as x such that x square is greater than 5x plus 6. Think about this. 3, set C such that okay, determine this set x such that sin x greater than 0. You determine these sets, right? So you try to investigate these sets and what are the elements which satisfy this inequality. Fine. So these are applications.
Sir,
Yes.
sir, I had this question like while solving these examples, there is no such particular way कि बस इसी way से solve करना है.
No, no, there is no way. You have to observe the problem and then you have to decide the strategy.
Okay. और बस it should be बस mathematically correct.
Yes. It is not necessary that you should follow my way, right?
Okay.
You can have a smarter way than me, right? You can have a better way
I'm
than
dumb.
me. And again, philosophically, what is a smarter way? Which is a better way? So, suppose you use mobile and various softwares. So, which mobile is better? Which software is better? So, if you open some software and if you perform something in that using that software, and if works fast, right? If it works fast, then it is better, right?
Yes, sir.
Right. Suppose you use some calculator or computations using mobile or any gadget, and if it gives you the answer in very short time, right? Many times what happens if you perform some operation and then it takes some time in mobile or whatever. It takes some few seconds and then it gives output. That happens. So that is because the process is very slow. Right. And why process is very slow? Because there is the mechanism is going on in behind in the software, and that mechanism is a program. Right. There is a program, and that program, how this program is executed. If it is executed very slowly, then it gives you answer very slowly. But if your program is faster, then it gives answer in very few steps. And therefore, similarly, if I solve some problem, right? If I solve some problem and I solve problem in suppose 10 steps. I have written one step, two step, third step, and I solve the problem in 10 steps. And suppose somebody solve same problem in 5 steps. Right. So which technique is better economically?
The
Five
five-step
steps.
technique.
5 steps. Why 5 steps? Because ultimately the same problems when you write the program in some software, then you have algorithm. And what is the while solving problem we have some algorithm, logical algorithms. This because of this, and because of this next step, because of this next step. And if some of you might know the C programming or Python programming, then they can understand that there is a program, there is algorithm,
Yes, sir.
and algorithm exactly behaves
Yes,
like
sir.
our proofs of theorems or proofs of problems, right? And therefore that algorithm, so solving problem or writing proofs of theorems is nothing but writing algorithm. And therefore if your algorithm is a better, that means it is in less number of steps, then it will be executed in less time. And if it is executed in less time, then it is economically convenient. Right. That is what the computer science is doing. how they use mathematics, they're using mathematics in this way. They are trying to get the methods, shorter methods, so that their algorithm work faster, and they'll get the in less amount of their program will be executed. Right, and therefore, if you want to get the smarter technique, then you need to understand mathematics from deep. If you understand mathematics from deep level, root level, then you can understand how can you reduce your size of algorithm.
Okay, sir.
Right, so that's fine. Okay, so I think it is near about 2 o'clock. So if you have any doubt, any difficulty, you can ask. Next time we'll start with new topic, that is absolute values, and we'll try to understand the properties of absolute values. So are you comfortable with the whatever is going on?
Yes, sir.
Right? Do you understand